This is the area where the mixing is done. All the materials that are used here are extremely heavy viscous materials, and therefore these heavy machines are required to mix both component A and component B of the epodynaweight. Both materials are made hot and packaged hot, and even so the viscosity of component A is so heavy that it still requires manual packaging. Packaging is done by hand. The material is compacted so that even fill levels are quite obvious between component A and component B. Here you can see that the levels after fill and compaction of component A are equal. The machine where component B of all these various products, at this present time, standard dynaweight is being mixed prior to being filled in the 2-pound containers. Component B of standard dynaweight being filled in the 2-pound kits. The material is filled, as we mentioned before, hot and allowed to cool normally before final testing and packaging. Each batch of epodynaweight is manufactured and subjected to several quality control procedures in conjunction with our quality control program, after manufacturing and before final packaging. A sample of each batch is brought into the laboratory and allowed to cool naturally after manufacture to room temperature. Batch numbers are then recorded along with customer names and part numbers where required. A sample of dynaweight is then mixed and mixing qualities are carefully checked. Following mixing, the color is compared against previous cured samples and color standards for accuracy. Pot life is then checked. Spin testing. A 1-ounce sample of mixed material is placed on a 1-inch diameter polished steel shaft, and then that sample is rotated at 1750 RPMs for 60 seconds. The material shall not fly off in the uncured state and shall not be significantly move or creep from its original shape and position. Results are recorded and rated by the pass-fail method. The spin test is further used to determine the length of pot life. As long as mixed material is capable of passing this test, the material is considered workable or usable, and pot life extends to the point where this test is no longer passed. The dielectric strength of each batch is determined by the use of a junior high pot tester in accordance with method A. Following dielectric testing, the test specimen is checked for surety hardness, which indicates, of course, thorough cure. After surety hardness testing, a sample is placed next to a comparative peg and allowed to cure to determine slump of the material. The material will not slump nor move away from the height of the peg to properly pass this test. All results of of all tests are recorded and test records are kept for 2 years. After the Dynaweight has been mixed and packaged in individual cups, it's brought to this area for the final packaging after all laboratory testing has been done and all batches are ascertained to be of proper quality and consistency.